So at Slant 3D, our operating goal is to become a warehouse where the shelves make the product. A system where you can just upload a file out of the blue and get a final finished part in the mail a couple of days later. And there's a reason this is a fantastically difficult problem. Even though parts for years have been made on demand for people. All the way back in the old days, people would make a chair for you. Today, machine shops will machine a part for you, and of course 3D printing will 3D print a part for you. And it's really not that odd. But the problem is, and historically has always been, that there's always been a component of time. Because if somebody's making a part for you, they have to get feedback from you, get the design from you, verify that the final piece is what you want it to be, and then send it along to you. And while this has improved in recent years with improved technology, it is still a concern because getting a final finished part out of the blue is exceptionally difficult to do in any sort of large-scale manufacturing context. Now, again, most of these companies that do print on demand or other similar type of operations, where an individual works with a client and then creates the part and understands what the client needs and has a very deep personal connection with the part, and therefore are able to tune and twist and see. This person is often very highly professional and able to very quickly understand what the complexities of the product would be for that one-off part. The other issue has been, it's just really expensive. To make a single prototype piece is a large endeavor that is a very expensive thing to do. You would be spending hundreds of dollars for the initial part, sometimes even thousands, in order to pay for that timeline of a professional person working very hard to make sure your part is exactly what you want on the first try. This is not print on demand, this is prototyping, this is art. And in order to take that art and scale it up is very, very difficult. In our context, warehouse where the shelf makes the product, the technicians inside of the warehouse cannot have to know about what your part needs to be. The part needs to come off the machine fully complete, ready to go, or be able to go through some process to be verified and inspected and make sure that it's up to certain tolerances and variation differences and controls. All of that is a tough process to set up because that is a manufacturing process. In order for it to be affordable, we have to do it at very large scale and we have to do it very consistently. But the problem is, most manufacturing processes are set up to deal with one single part. The case of an iPhone, the chip, some weird bracket or widget coming out of a single machine. It's very easy to mass produce a single part because you can set up all the parameters in the entire assembly line around that single part. But if you have many different parts, or even worse, have no idea at all what part will be coming down on any given day, it has just become exponentially harder. Now, 3D printing has enabled this a bit. It is a process that can reliably produce a part. But the design of the part is so important for any manufacturing process that guaranteeing that a part is good quality when it comes off a machine and meets the expectations of the designer who may not have intimate knowledge of 3D printing is a very difficult thing to do. Because now we have to build a manufacturing process that is as robust as a human. Able to look at a part and understand, that's a little bit off, without there being actually an explicit definitional statement or a standard operating procedure or anything else for that individual part. How do we create rules that apply to everything and can be applied at a large scale? Now, we need the large scale in order to keep costs low, and we need to be able to allow the system to self-correct itself because we can't always rely on technicians to be aware of what's going on. Humans fail, and at large scale, humans fail very often. So this is why it's such a difficult problem. We are taking mass production and making it custom, which is so hard. Mass production is so easy to set up because you have jigs and tools and dies and standard operating procedures for a few parts to where it's very easy to say, we plugged in this, it doesn't fit underneath this measurement, that's what it is. But if one day somebody sends you a bracket and the next day somebody sends you a dragon figurine, the rules are completely different between those two products of what the customer might want. Really, the thing that can kill a print farm such as ours is the fact that we can make anything. So how do we make anything when we have to make everything? So this is what we work on continuously every single day, making the machines more reliable to make sure that the output is consistent and reliable. Adding more machines so that the cost is low enough and there is enough redundancy built in to make sure that parts are produced reliably and quickly. And then also working with materials and suppliers to make sure that, again, reliability is as high as possible. But even now, once a part comes off of a machine, it has to go through a post-processing and inspection process. And while that is highly manual right now with several standard operating procedures around how to do it, it is something that has to be automated. Otherwise, it can't physically be done into continuously large scales. Right now, we can produce hundreds of thousands or millions of the same part for a client and do it consistently and reliably. But we cannot produce hundreds of thousands of individual parts and do them for the same cost and same speed as we would that individual mass-produced part. But this is the holy grail of what we're going after, because if we're able to crack it, it positions us so well to create any product at any time and create a world where nothing ever exists until someone actually orders it. Have a great day, everybody.